Welcome back, everyone. Today I'm going to be showing you how easy it is to get started in 3D printing. I've been printing for not even 24 hours and this is what I've come up with. I've gotten a vase mode, polymetric figure. I've got a 75% benchy, a 100% benchy, and then 2 test cubes. And this is with no truly failed prints. There were a couple test failures just trying to get the first layer right, but other than that, this is everything I've printed with very good results. So I'm using the Ender 3. This 3D printer costs, when I bought it, $189 US. Shipped. That is to my door, $189. I don't think you can get much better than that. In terms of results per dollar, in my opinion. The next thing is the filament that I'm using is up here. That is just cheap filament off eBay. It was $15 for that 1 kilogram roll, and it prints really, really well. There are a few artifacts in the print quality that are very minute, but otherwise it is what I would consider to be a perfect print. Same with the 2 benchies. The overhangs are perfect. The arches, like these circles, are pretty much perfect. And these are actually a lot more durable than I thought they would be. Like, this is just 1 layer thick, so it's pretty weak. But these, like, you would have to really try to break these. I apologize. I lied a little bit. I also printed off these 2 pieces. These are stands for the Big Clive supercomputer, and these are very durable. I don't know, again, you'd have to really try to break those. So the strength of the parts is also quite good if you're getting good layer adhesion. The material, by the way, is PLA, polylactic acid. It is a sort of biodegradable, sort of compostable plastic, so it's probably one of the least environmentally damaging plastics you can do. So how do you get here? How do you get to these finished parts? Well, first you need to find an STL file, a .stl file. Those can be found in the form of this, which you just drag into the slicer. And there's the part. And continuing in this reverse process, where do you get the slicer? Or what is a slicer? A slicer is the software that is used to create the toolpath for the part. As you can see, this is the toolpath for this part, and this slider here is all of the layers. I'm using the Prusa slicer. It is available for Windows, Mac OS, and Linux. It is also completely free, and it is very easy to use. I'd recommend this, but you can also use Kira, and I think there are a lot of other slicers out there, but I think Kira and Prusa are some of the most popular. And the way that you can get an STL file, the easy way, which would be on Thingiverse, or there might be some stuff on GitHub, but Thingiverse is an easy way to get free STLs. You just search it up here, anything you want, you can probably find it. And then you just download all the files, and that will give you an STL. Or you can do something like Fusion 360 if you want CAD software, FreeCAD, OpenSCAD. There are a lot of other options, and some of those you have to pay for, some of them are free. Take your pick there. But once you have this sliced and you've gone through all the settings, which Prusa makes very simple if you want it to be, or very complicated if you want it to be. And then you can just export your G-code down here. When you do that, you'll get another file called whatever this file name is, .gcode, and you'll put it on an SD card. You then take the SD card and you put it in your 3D printer. Then turn on your 3D printer, and here is the configuration screen. And you can scan through all these settings. You can go to Prepare and do Auto Home. And now it is at home, which is 0, 0, 0 in the X, Y, and Z axis. That's not strictly necessary, but it's something that's, I think, good to do. So if you go back into the menu and then go print from TF, here is everything on the SD card. And you can just choose something here to print. Let's say I wanted to print another supercomputer stand. Alright, now the nozzle and the bed are going to start to heat up. The top numbers is where it is set to, the bottom numbers is where it's actually at. However, because I don't want to actually print something right now, I'm going to go down to stop print. And now it'll set everything to 0. And that's all you have to do at that point. What you have to do to make sure that it's going to print on the bed correctly is you have to do something called bed leveling, where you make sure that the nozzle on the 3D printer down there is the correct height above the bed. If it's too low, it's going to crash, and if you're lucky, it'll just kind of scratch the surface. If you're unlucky, you could actually break something. If it's too high, then your first layer isn't going to adhere properly. So it's very important to get that measured out correctly. And there are a million videos that will do better than me at explaining how to do bed leveling. So that right there is all you have to do. Get an STL file, put it in Slicer software, get it on an SD card, put it in the printer, press print. It pretty much does all the rest. Print times are pretty slow. Let me show you. So this one part here that I have sliced is going to take 30 minutes. 30 minutes for one of these, but you can change that up here with layer height. You change the layer height to something very small, and then you re-slice it. Now this same part is going to take 1 hour and 16 minutes. That's just because of the thinner layers. So you can really play around with how long you want it to take. Conversely, you could also add or subtract infill. So I went from 15% to 50% infill, and now it is going to take an extra 30 minutes. But with more infill, the part is going to weigh more, it'll be more dense, and it'll be more strong. So it really depends on your application. Do you want something fast and weak, or slow and strong? Also, the bigger the part is, the longer it's going to take. This cube, with the settings I had, was about 40 minutes. This took about 1 hour. This benchy was about 1.5 hours. The smaller benchy was about 1 hour. And that's all there is to it. This is a very simple system. And that's all with pretty much factory settings, very little tuning, and very little tweaking in the Slicer software. And you can get parts that look, this good. If you want to go and turn your dials and, flick some switches to make some better parts, absolutely do it. You're going to get a better experience. But that's all it takes. $15 a filament, $189 of a printer, and yep, that's pretty much it. And you will need a computer to have some Slicer software, as well as get all your STLs. Again, you can probably find some G-code, some raw G-code, but I would not recommend that because that G-code can have your machine do literally anything. So it's better to get the STL, which is just a 3D file format, put it in the Slicer yourself, and then export your own G-code. If it seems that is too simple and you think there's more to it, there probably isn't. That's really all it is. So hope that is helpful, and until next time, see ya.